Thank you. So I'll just write it out. Oh, that was good. Haha. We need to combine our three. You are writing this in your lab book, right?
Yeah.
Into one beautiful equation representing an object moving moving in uniform circular motion. I do appreciate the lack of noise right now. Everybody good with that basic idea? That's what we want to do. And that's why I'm doing video of it, because it's like harder, because you have 3 separate investigations. How are you going to combine them? Well, they all have the same dependent variable. That's what unifies them. Okay? So here we go. So you have evidence that T is proportional to M. Everybody good? You got evidence that T is proportional to V squared, and you got evidence that T is proportional to 1 over L. Notice the symbol meaning proportional to. Yeah? Go. Cool bananas. This is a trick. How about if I say, okay, therefore, T must be proportional to, T must be directly proportional to mv squared over L. Cool bananas, do you see what I did? So this is going to take 100% to get this. This is hard. Do you see what I did? I just multiplied the independent variables together.
Is that
Okay?
mathematically allowed?
Well, here's what I'm saying. I'm saying that if I graphed T versus mv squared over L, I'm saying, look, that was linear, and that was linear. Thus, this should be linear. Make sense? That's all I'm saying. Go. Can't hear you. Hold on.
I remember from the beginning of the year that when we were writing this about direct proportional and direct proportional, you had an equation we just had to take it apart by saying, because these are just like being multiplied to each other, they were direct proportional. So I see what you did by just combining them. You reversed what you did at the very beginning.
Wait, say again? I reversed what you did?
No, we did at the very beginning. Before we had like...
You're saying I'm doing it backwards now.
Yeah, because we had like one equation like
Yeah.
totally. We had to find relationships just based on the equation.
Yeah. Yeah. Good. So here's the major step. If that's true, and I want a general equation, please don't miss this part. If I want something general, if this is true, doesn't there have to be some slope value k? Just making up a slope value k here. Doesn't there have to be a k value, a slope value, such that if I knew that k value, I would have the general equation unifying my 3 investigations? So I'm going to call it k, and I'm going to say, my goal is to find k. Got it? The slope of this graph. or the value in this equation, it's whatever's here. Because this is in the form of y equals mx plus 0b. Good? Your questions are awesome. They really make this better. I'm staying too far back from it. Scared of it. So, here. Check it out. Let me rearrange this. I'm going to rearrange it 3 ways. T equals... I got to figure this out while I'm doing it. K v squared over L times M. Is that the same thing? You guys see what I did? You know that? You know how I could like, I could make you all switch seats and stuff. Well, like it's the same thing. Mathematically, you can rearrange them. Go.
I said we're proof of that.
Yeah. So I'm gonna do that same property again. I'm gonna rearrange things again. I'm gonna write. Let's see here. K M over L times v squared. Do you guys have any idea why I'm doing this? You don't have any idea why I'm doing this. Let me help you see why. Check it out. If I take this, hold on. If I take this particular thing I blocked in, this, if I circle in red, is the slope of which graph? This has to be the slope of t versus m. It's in the form y equals mx plus 0. So this is the slope of t versus m. And you have that. Are you guys with me? Did you do this investigation where you changed the mass?
Yes.
Do you have a graph of t versus m that's linear?
Oh, yeah.
Do you have a slope value?
I'm sure.
It gets better. When you did this investigation, was speed constant?
Yes.
Remember I said to write it down?
Yeah.
Was the string length constant?
Yeah.
So you have everything in there except k. And you have that. So we have a simple way of setting up an equation here. Check it out. You can just go like this. You can say, all right, here's my equation. I'll do it in a different color. Slope of t versus m graph, my results for that slope have to equal my k value times v squared over L. And then I can solve this for k, because remember we said we were going to try to find k. If we knew k, we would know our general equation. So k has to be the slope. I'm rewriting all that. I should actually use the smartboard for what it's good for. I can take this. Oh, this is fun. Oh, it didn't really work. I should have just written it. K equals slope of t versus m graph times what? Over what? I'm solving this for k. So v comes down below. This is over v squared times L. Do you guys see it now? I simply solved for k. Cool? Good, good, good. Okay? We're almost done, actually. Okay, ask your question again when I'm thinking.
Sorry.
No, it's okay.
I thought you said K was the slope, so I started.
Okay, K, let's go back up for a moment. You guys are awesome. I love the questions. K is the slope of a totally different graph. K is t versus mv squared over L. It's the slope of our... K allows us to find our general equation.
Got it.
This slope down here is the slope of our t versus m graph. Okay. Someone who has their lab results handy, please give me the slope of your t versus m graph and give me the string length that was constant and give me the speed that was constant, please. Okay? I'll plug them in here. I need all of these. So, nobody in here's got them?
The slope is 0.9967.
0.9? Oh, that's cool. And the units, hold on, the units, thank you, that's good so far. The units are newtons, because it's T versus M. Newtons per kilogram. You guys with me? What's L? I'm gonna guess. Let me read your mind. It's 1. Wow, don't tell me what speed is. It's 1. It's 1, huh? What were your exact numbers? I can almost hear you. Hold on. Okay. So I'm gonna call it 1. 1 meter. Yeah? Thank you, Kershi. And what was the speed? I knew it. So 1 meter per second, but you notice it's speed squared, so I'm going to put it there. Everybody good? Watch what happens. This is beautiful. When I simplify this, I'll just write the 0.99 here. That's what the number is going to be in the end. Newtons is kg meter per second squared, right? You guys good with that? And kg can stay down here. Meters can stay up there. Meters squared per second squared. Do you see what's happening with the units now?
Somewhat. The second squares cancel.
Just the second squareds cancel?
No, the kg.
The kg cancel?
One of the m's with the m squared.
Only one of them
no,
cancels.
there's 2 m's.
Do you see?
Cancel everything.
Yeah. And you're left suspiciously with 0.99.
So that's the value.
Okay. Now, this is going to require a lot of imagination. In an ideal world, what would your k value be, you think?
1. 1.0.
If k equals 1, then go back to our original equation. What is our original equation? It was scrolling up. What does t got to equal then?
What is what?
What does t got to equal then?
I saw a video. Not even in the camera.
I know, that sucks. Actually, it's good for them. They don't have to look at me.
Well, the board thing is off, right?
Yeah.
You're not
What does T
confident
have
enough in your books.
Oh, I'm perfectly comfortable.
He's married.
Okay, I ask again. If k is 1, what's t in general?
mv squared over l.
Cool.
Squared over L.
So that was one investigation.
That's only one of them?
That was all, we only used,
Oh, right.
so t equals mv squared over L. We only used data from our t versus m investigation. Imagine if all 3 investigations agreed upon what k was. Imagine how strong that evidence would be. This is so far looking pretty good. But then, when you look at the rest, let's see what happens. So I rearranged my equation a second and third way. Okay? I rearranged it as k times, I'm trying to remember it, km over L times v squared. Remember that?
Yes.
And I would argue that this is the slope of which graph?
V squared.
Good. Slope of t versus v squared graph. That's throwing me off. Okay. So you have everything you need. This is what you use to solve for k. K m over L has to equal slope of t versus v squared. Kershid, do you have more for me? It's nice if we stick with yours. Did you end up linearizing your t by t versus v squared, and it became linear, or no? Okay, I'll use someone else's then. That's cool. Go ahead.
Okay, the slope of this one was 1.998.
Okay, so 1.9, and your constants, unlike Kershid's, no, nothing bad. Your constants were not 1. In other words, m and L were not 1. They weren't exactly 1. I know this already by looking at that. Anyway, I'll continue now. This has to be newtons over meters squared per second squared, correct? Everybody sees I figured that out? It's a t versus v squared graph? It has to be that. Okay, so this has to equal k. What was the mass you held constant in that investigation? Yes. I need m and L, please.
L was 2.
Okay, L would be 2 meters then, right?
Yes, and the other one was 4.
Good. You're gonna like this, I think. I'm really happy about the first one we did had all the constants were 1, and now the constants are something different. This is gonna be cool. So let's solve for k again. K is gonna equal 1.9. Can I replace newtons with kg meters per second squared? You mind? It'll make things easier. Okay? And then I'm going to flip this over. I'm going to put the second squared up there and the meters squared down here. Do you see why I did that?
Yes.
I'm just saving myself a little headache later. Okay? And then the 2 meters is multiplying into this. Is that right?
Yes.
And then the 4 kilograms is going to be in the denominator. So I'll put it down here. Everybody good?
Yeah.
I'm kind of just doing this on the fly. Cool? All right. And I'm hoping this works out. It might not, and it's not the end of the world if it doesn't. But I think this is a good sign. Kilograms cancel, meters there and there cancel, seconds cancel. I'm feeling very good about this. 2 times 2 is 4 divided by 4. This is interesting. Because that's about 2. Right? Is this number a little more than 1, a little less than 1? A little less than 1? 0.99 or something? So all right, 0.9. I don't know. I know it's a little more, a little less. Oh yeah, it's a little less. I'm stupid. I got it now. You guys cool? So again, if there were no error, I think you can see that if k equals 1, then we're getting more compelling evidence that t equals mv squared over r. I'm thinking of something else. You'll see in a little bit what I'm thinking of. All right? Excellent. What's the only one we haven't done yet? T, we rearranged to k, m over v squared, 1 over L. That's the only one we haven't done?
Yeah.
Okay, good. So this is the slope of which graph?
Your string length versus
Good. So slope of t versus 1 over L equals k m over v squared. All right? So I'll need someone to give me those values, please, after I solve for k. K is going to be equal to slope of, so please look those values up for me if you don't mind. 1 over L times v squared over m. Are you guys cool? Sure. Is that good? More? Okay. No worries, home chicken. Everybody good here?
Yeah.
Okay, so I need this, that, and that, so I can finish this. Oh, sorry, haha. Just kidding. Here.
The slope is 35.73.
Okay. I'll do it here. So it's 35.73?
Wait.
36?
Whoa.
Well, what? Sorry. Go ahead.
No.
Okay. Cool bananas. 36. It's going to be newtons over 1 over meter. Is that right?
Yes.
You see how I got that? Because newtons is that, and then 1 over meters should be that. Okay? V, please. What'd you have for that?
V was 3.
So you got 3 meter per second. Don't forget to square it, so I'm going to write it again. That's probably a really common error.
And then mass was 4 kilograms.
Don't be sorry. It's okay. I might have messed up. So what'd you say?
Mass was 4 kilograms.
So it's 1. Okay, give me just a second. Sorry. Did I make an error? I hope I did. So you said 4?
Yeah.
Okay, go ahead, homeboy.
How come 1 over L is taken out, but then B squared is on the bottom? Shouldn't it be on the top?
So K on B squared. Go to the slope of T versus omega.
You guys see the error? I did make an error.
What?
Yeah.
You guys are champions, dude. You guys are awesome.
Awesome.
Okay. There's my error right there. That V, here, let me ungroup it and I'll move the V up. And then you're awesome. Okay, so ungroup. Love it. That goes up there. And this goes up there.
Oh, I get it. It's the
What's
bottom.
that then?
There.
Well,
Yeah, I get it.
Oh, because MD squared was
Thank
all,
you.
right?
Yeah.
Now are we good? Except I gotta move. Hold on. Hold on. No, it's good. The computer is running slow because it's trying to video and do smartboard, and it's like, no. I need a better computer. V squared here. Are you guys good with what I'm doing? I hope it doesn't drive you nuts. I make mistakes all the time, and this is typical.
We forgive you.
So how does this change things? When I solve for k, v squared is going to be in the bottom, right? So I'll just erase it. Okay? So it's going to be much cleaner, I think. And the units, you know what the beautiful thing with units is the units would have caught this error, and I would have been like, because the units wouldn't have canceled. So how do I fix this? This is divided by mv. Is that right now?
Yeah.
And so these actually go, I'll just rewrite it. How's that? You'll read me the numbers again, please. All right. So what was the slope of the t versus 1 over L?
36.
So 36. And the units would still have to be newtons over 1 over meter, right? So that's my slope. Now I'm going to multiply by 1 over mv because I think it'll look prettier. So I'm going to write it like that. M was what?
4.
4, that's kilograms. And this is v squared. I'm sorry, almost another error. I can't see the square up there. And it was 3, you said?
Yes, 3 squared.
Now, 3 meter per second, 3 meter per second. So what number do we get when we divide 36 by 4 and divide by, okay, 4 times 3 is 12 times 3 is 36? What's 36? Oh my God. Is that cute? Is that cute? Now, the units should work out as well. The units are going to be kg meter per, so we know we get 1, kg meter per second squared, kg meter per second squared, and then if it's 1 over meter in the denominator, that means I can put meter there. Is that right?
Yeah.
Okay. And then this is kg, and why don't I upside down thing that one? Reciprocate it? Is that, no, that won't work. I did it wrong. I reciprocated it wrong. Second squared will go there, meters squared will go there. Is that correct? So now we're good. Cool? There's only one, I think you guys got it. I mean, I don't even need to write it, but I will. If k equals 1, then t is mv squared over r. Cool, bananas?
Wait, why did you say R? Isn't it L?
Oh, I was just going to say why. You're awesome. Here. I might as well say now since I keep doing it.
Yeah.
If you notice, I keep writing R
Yeah.
because it's so pounded in my brain that in this case, the simulation we used, let me find it. It should be running. Here it is. There it is. Whoops. Almost. There it is. Please observe. It can barely run because they're so low memory. Assume it were constant speed going in a circle. That's what it should be. The string length, is it not the same as the radius of the circular path? I mean, you think this equation is only good for things attached to strings going in circles?
Anything in
What's-
circular motion.
That's what makes it so powerful. You think of driving. If you're driving through a beautiful mountain road and you're going constant speed around a turn, where does this, what am I trying to say? Any curve can be made into a circle of different size. You with me? And the radius of that circle is what we're talking about here. It's the radius of the circular path. It's not always string length. In fact, it's hardly ever string length. Make sense? And it's going to take time for you to really understand what this equation means. And the tippers, I think, are going to be the most valuable in the beginning. So I'm going to emphasize those right now, as well as problems 1 and 2 on your worksheet. So we'll start there. Are you guys good with that? So that's what you want to do. I'm going to post some tippers on the website where they'll be like conceptual. And those are going to help you a lot. It's actually good to get them wrong. And then try, after you do those, then try the worksheet problems and see how it works out. Are you guys good with the homework? And you can refer to this video if you want to kind of review it.